Hey CP Math 1, so we're going to continue practicing writing and solving systems of equations based on context. So this is a problem that we're going to do right now, but I got to go check the door real quick. So in this particular problem, it says a paper company needs to ship paper to a large printing business. The paper is going to be shipped in two types of boxes, small boxes and large boxes. So as soon as I see this, I'm thinking variables, right? So one kind of box is small, the other kind of box is large. In fact, let me use a second color for that. In fact, I'm going to actually define variables right now just based on reading that. So I'm going to say let S be the number of small boxes. Oops. And I'm going to say it's just because S is such a, or L is such a bad number because it looks like 1. I'm going to say let G be the number of large boxes, L-A-R-G, that's why I picked that, boxes. And this problem says that each of the small boxes weighs 50 pounds and each of the large boxes weighs 80 pounds. So I've got a weight associated with each of those. The large boxes are 80 pounds. The small boxes are 50 pounds. And the other thing it says the weight, this is another piece, I'll highlight this in orange. The weight of all the boxes was 1,750 pounds. So I can write an equation that describes the situation from the weight. In fact, every single small box, S, weighs 50 pounds. So I can say 50S, that's the weight of the small boxes, plus 80G, that's the weight from all of the large boxes. And together, the total weight is 1,750 pounds. The other piece of information that's here, and I'll underline this in blue, is it says there were four more large boxes shipped than small boxes. There were 4 more large boxes shipped than small boxes. There were 4 more large boxes shipped than small boxes. So I could literally read that to myself a lot. But there was 4, so there's more of the large boxes. So if G is the large boxes, right, and S was a small one, I know that if I increase S by 4, these are the equal quantities, right? So it says here, what this says is that G is 4 more than the small boxes. G is 4 more than S. So these two equations together comprise my system of equations, and this is a great system for solving using substitution. And the reason why is the second equation tells me what G is. It says G is S plus 4, and I can substitute that value into the top equation. So I'm going to rewrite that top equation. I'm going to write it as 50S plus 80 times the quantity of S plus 4. So you can see I just wrote down there what G is, and that equals 1,750. If I distribute, right, I've got 50S plus 80S plus 4 times 80. 4 times 8 is 320, right? 4 times 8 is 32, yep. Plus 320 equals 1,750 pounds. If I take away 320 from both sides, I got 1,750 pounds minus 320 pounds. This is going to give me 130S equals 1,430 pounds. And finally, if I divide both sides by 130, I get that the number of small boxes is 11. Now, if the number of small boxes is 11 and G, the number of large boxes, is 4 more than that, I know that the number of large boxes is 11 plus 4, which is 15. So together, right, both conditions are met. The number of large boxes is 4 more than the number of small boxes. And if I take 50S, let me grab my calculator here. If I take 50S and there we go, 50 times S was 11. 50 times 11 and I add to that 80 times G, 80 times G, and G is 15, I do get 1,750. So this completely checks. My solution is that they are shipping 11 of the smaller boxes, and they're shipping 15. Whoa, I don't know where that just went. And they're shipping 15 of the larger boxes. All right, so that's it. That's the one thing that I wanted us to walk through today.